Good morning and good afternoon to everybody. I'm Andrea Menghini from GeoMax support and training team. First of all, I want to thank you to have joined this webinar about the Zenith40 receiver and the Ppp, the precise point positioning solution. This is the first webinar of a list of webinars open to everyone that we are starting since a few weeks. We decided to run this webinar project open to everyone because most of us are at home due to COVID restriction, and we hope we will keep you busy with a webinar for each week till June. Just to give you more information about our webinar calendar, on our website it is also possible to find all the webinars that we will run during the next weeks. And from the website, it is also possible to directly use the link for the registration. I will show also directly on our website. So this is our website. In Home About Event Calendar, you can find directly all the other webinars. Let's start with the topics of this webinar. During this webinar, we'll talk about the precise point position solution. We will talk about the convergence time, so how the solution works, and all the functionality behind this solution, how we can work with Ppp solution on our receivers, and how it works, the positioning adjustment. If you have any question, feel free to write me directly in the GoToWebinar chat. I will reply to all the questions also during the presentation or at the end of the presentation. Unfortunately, we cannot share this presentation, but you will receive an email tomorrow also with the video of this webinar. So let's start with the precise point positioning, so Ppp solution. What is the Ppp, so the precise point positioning solution? It's a global navigation satellite system positioning service with a worldwide coverage correction service that is delivered to end user by satellites. The Ppp is able to provide correction with very precise positioning, so it means an accuracy of few centimeters. The Ppp correction is different from the standard RTK method, which use a fixed base receiver in field, while in the Ppp the correction is delivered directly by satellite. So it means that it will be available everywhere. I would like to say a few words talking about how the accuracy is calculated. If we talk about the standalone position, means that we are using the GPS and we are start to track the satellites, more or less the accuracy of our position will be plus minus 5 meters. So without any kind of RTK correction from base or from the course network. So we can't use this accuracy for the topographic job. But why is a plus minus 5 meters? Because there are several positioning errors, technical called bias. But what are the bias? The resulting error corresponds to the sum of three error types, so three bias errors. The first type refers to satellite clock. So inside each satellite and inside each receiver, there is a clock. The clock inside the satellite is much accurate than the one in the receiver. But anyway, we have an error. So, for example, Galileo uses better clock material quality that allow to improve the efficiency in comparison with the other constellation, other satellite. Since the position is calculated considering the time information, we have an error in the position. The second error refers to the multipath signal error and also for the phase center offset of our receiver. And then we have the third error, the last one, probably the biggest error in the spatial related error, depending on ephemeris quality, ionosphere, but also troposphere. So what is the middle between the satellites and our receiver? The sum of these three errors create this 5 meters error. So it's a result of the sum of these three errors. With the Ppp service, these errors are migrated through different way, to this way. The spatial error, in particular the ionosphere delay, can be eliminated by using a dual frequency GNSS measurement, like, for example, using our Zenith40 receiver. Then the external error correction, which includes satellite orbit and clock error, can be eliminated with the TerraStar service. Due to the Inmarsat telecommunication satellites, so the system operated with the frequency range allocated by International Telecommunication Unit for mobile satellite service. So basically, the external error can be corrected by a third-party service. In our case, we will use the TerraStar service. Then the tropospheric delay is modeled and partially estimated by the service. Then, so the last way, we have the Ppp filters. We will see also later during the presentation. In particular, we are talking about the Kalmar filter, which is used to estimate position, ambiguity, and receiver clock error. But it will, as I told you, I will explain it later also during the presentation. So to summarize, what is the Ppp? The Ppp depends on GNSS satellite clock and orbit correction generated from a network of a global reference station. We can use this service to reach better position accuracy without any kind of RTK network or base station correction. The only limitation is that this solution requires a period of time to converge to decimeters accuracy in order to solve the local bias errors. This is more or less how the system works. Our receiver can track GPS, but also GLONASS, so minimum dual frequency receiver. So in our case, Zenith40, but also Beidou and Galileo, so other constellation. There are some reference station and control center on the ground that calculate and send the correction to geostationary satellites that provide the correction to our receiver. So in our case, in our basket, the Zenith40 receiver support the precise point position, so the Ppp solution and L-band services, in our case provided by TerraStar. Ppp is a paid service correction, so you need an annual fee So the correction, as I already told you, is delivered to end user by satellite. It's more or less similar, as more or less the same structure of a S-bus satellite system. So, for example, for X-bus, we can use the EGNOS. The difference is that the PPP is more accurate. So, for example, with the S-bus, we can achieve more or less 40, 70 centimeter accuracy. With the PPP, we can achieve few centimeters accuracy. But on the other side, we need to consider that the PPP service is not free. So if you need to check also, if you want to check also more information about the TerraStar solution, you can also have a look at this link. So we have directly the connection to Novatel website, and you can also find more information about the service. The PPP system is a worldwide system, while the S-bus system are regional. So this is the second main difference between the two systems. Just to resume, in general, PPP consists of the following elements. So we have a global network of reference stations that provide their data to a processing center, so network console center, that computing precise satellite clock and orbit correction and adjustment, and send this correction to a ground uplink, which transmits the data to a L-band satellite. So more or less is the same procedure that we already have seen during on this slide. So the adjustment is sent directly to geostationary satellites, and then from geostationary satellites to our receiver. So that broadcasts the correction data to GNSS customers. So in our case, to Zenith40. Let's talk more in deep about the TerraStar. TerraStar is a Hexagon company. Is a global leader in the satellite-based correction service with a global network of over 100 GNSS reference stations composed with 3 network control centers, geographically separated, also with 7 geostationary satellites to end user equipment, and the correction data transmitted over a minimum of 3 beams directly to end user. It's a service that is open 365 days a year, 7 days a week, 24 hours a day. So you can use this service in any time with all the weather and correction service. So let's talk about the accuracy that we can achieve with the TerraStar solution. Of course, TerraStar offers various services levels with different performance level. So in our case, so using our Zenith40, we can use the TerraStar C Pro. You can also check the main difference between the different services provided by the TerraStar solution. So in our case, we are using the Zenith40 equipped with the OM7 measurement engine. So is supported platform, and the TerraStar C Pro service. So with the TerraStar C Pro service, we can achieve more or less 2.5-3 centimeter accuracy in horizontal and 5 centimeters in vertical. Also, from this link, you can find more information about the TerraStar and also the new releases provided by the TerraStar service. But in this case, we need to talk about the convergence time. Why the convergence time? Of course, the TerraStars support GPS, GLONASS, Galileo, and Beidou, but to achieve this accuracy, we need a convergence time of about 18 minutes. So what is this convergence time? So we need to consider that the Ppp solution uses an algorithm based on an extended Kalman filter scheme, so which allows to estimate several errors. So we already talked about the bias error. We can compare the convergence time to the time needed to get the fix using a coarse network or local trip network with our receiver, so reference station network. But in this second case, so using a entry network, we need normally more or less 10-15 seconds to get the fixed status. While with the PPP, we need to track satellites for more or less 15-18 minutes, so less than 18 minutes. So both systems need time to estimate errors and achieve the centimetric accuracy. For the PPP solution, we need more time. So with the TerraStar CPro service, we need to fix the, we need to receive the satellites, the tracked satellites for more or less 15-18 minutes to get the centimetric accuracy result. So in this case, this is a screenshot from our field software Expad Ultimate. So you can really see there that the PPP is fixed, and here we have the horizontal accuracy, so less than 3 centimeters, and the vertical accuracy is less than 5 centimeters. Of course, we can track more satellites, so in that case, the software shows only GPS and GLONASS, but if you enter in the main menu of satellites, you can also find the other constellation. So how we can work with the PPP solution on our receiver, and in particular with our Expad Ultimate software. So first of all, we have two possibilities to work with the PPP solution. We can talk about the pure PPP solution, so without the RTK connection. In this case, if we are operating in an area where the RTK connection, the RTK network is not available, we can use the pure PPP solution to get the centimetric accuracy. After this solution, after PPP solution convergence is calculated, so less than 18 minutes, the receiver will get a PPP fixed solution with a centimetric accuracy. So we already seen in the first slide, in the previous slide, that here we have the PPP fixed icon, the accuracy that corresponds to the accuracy of the TerraStar CPro service. But we have also another method to work with the PPP solution and our receiver and our software. For example, we can use the PPP solution as a background for RTK connection. What does it mean? It means that we can configure the software to use both RTK connection and the precise points position, so the PPP service. With this configuration, the algorithm will choose automatically the best solution network between the RTK and the PPP. So to operate in this way, the position adjustment is necessary. So it means that if you are working with the RTK and PPP, we need to calculate the convergence. We need to calculate the shift between the two different network services. We will see also this in particular in the next slides. So this is a screenshot from our Expad Ultimate software. As you already seen there, we can choose different connection method, plus also activate both services. So internal, for example, the internal GPRS, so SIM card inside the receiver, plus also the PPP service. So this is this first example is using the PPP and RTK connection. So if the RTK solution is more precise than the PPP, the software will automatically use the RTK solution. For example, the RTK fix is about 1 centimeter, while the PPP fix is more or less 3 centimeters. So automatically the software will use the RTK fix. The second option, for example, we are in field and we lose the connection, we lose the fix and the connection to the service, the software automatically activates the use of the PPP solution. That, for example, in this case, we have a RTK float about 30 centimeters, while the PPP fix is about 3 centimeters. So automatically, the software will switch directly to the PPP service to use directly the PPP. Then the third example, so as soon as the RTK solution is again on fix, and it is the most accurate, so not only fixed, but must be also the most accurate. So for example, RTK fix about 2.5 centimeter, while the PPP fixed of 3 centimeters. So if the solution, if the RTK solution is again on fix and is again the most accurate, the software automatically switch again to RTK solution. So in that case, we can use RTK and PPP with the PPP as a background solution for the RTK connection. So after, in case we lose the signal, in case we lose the connection to the RTK network, the software automatically will switch to PPP solution. And in case we can get back the RTK fix, the software move again automatically to the RTK solution. So if we are using directly the PPP, the poor PPP, we don't need a position adjustment because the position is automatically calculated by the PPP service. While if we use the PPP and RTK in combination, we need to calculate also the position adjustment. So in that case, if we talk about the PPP, as I already told you, in combination with the RTK, is not a real PPP pure solution, but we need to calculate this sort of adjustment. In particular, what does it mean, positioning adjustment? First of all, we need to consider that the PPP is a global service and the PPP coordinates are calculated in a RTRF frame, so International Reference Frame. On the other side, each terrestrial plate moves constantly. For example, the European plate moves about 2.5 centimeters every year. So it means that the PPP that works globally and the local network are not referenced. So it means that the cartographic systems are calculated in a specific frame using different reference station for each country. So the cartographic system is localized to each country. That is in general different from the PPP frame that works globally. How we can do this adjustment, position adjustment in our software? First of all, we need to consider that this means that the latitude, longitude, and ellipsoid elevation in PPP is different from the latitude, longitude, and ellipsoid elevation from RTK network. So using topographic receiver, we can correct this mix of data between RTK and PPP using our software, in particular the position adjustment. So to correctly work with PPP and other coordinates, Xpad Ultimate, so our field software, must estimate this difference, so the shift between the two services. Xpad Ultimate, in our case, use an automatic procedure in the Ppp Manager, so it's a dedicated functionality inside the field software that could be used only with the Zenith40 receiver. So in that case, the Ppp Manager proposes that every new operation with the PPP this functionality. So we can select, for example, a previous adjustment, or we can create a new adjustment. So each time we use the PPP, the software automatically will open the Ppp Manager and ask us if we already have an adjustment, or if you want to use a new adjustment. So Xpad Ultimate calculate directly the difference comparing the latitude and longitude from the PPP and RTK position, or from PPP and no point. So for the first case, we will use the coordinates of the point and obtain from the average of a GNSS solution with the right accuracy. So for example, this is the screenshot from our software. While when we start directly the Ppp Manager, we have two possibilities to perform this adjustment, this shifting adjustment, using directly the connection to the RTK network and start to measure a point in RTK, or we can select, for example, a no point from the network, so we can enter directly the coordinates of the points that we are measuring. In this case, the procedure takes several minutes, and the time to have the PPP convergence and reliable accuracy. So at the end, as you can see there, the software automatically calculates this shifting. Okay. So as already said, the Ppp Manager, on the Ppp Manager, we can directly use a previous adjustment. That, for example, this is a previous adjustment in this area, performed in this area. So we can also check all the performed adjustment directly on the map, or we can directly use a new adjustment. So directly click on new to perform new adjustment. All the performed adjustment are saved directly on the Xpad data folder. So it's directly linked to a specific folder inside the internal memory of our device. But when is valid this adjustment? First of all, we need to consider that the data is valid not older than 60 days. Then the different position where we calibrated the system, and between the calibration of the system and the area that we are working in, are maximum 50 kilometers. So this adjustment is valid. Every adjustment will be valid with these specific rules: 60 days and maximum 50 kilometers distance between the adjustment position. So just to resume, how we can work with our software, we can use two different methods for the PPP adjustment. So, for example, we can use directly PPP. So we can select to use only the PPP without any kind of RTK connection. And in this case, every time we start a new job, we perform a new job, we need more or less 18 minutes to calculate the solution convergence. So to get the PPP fixed solution with a centimetric accuracy. In this case, the accuracy without any kind of RTK network correction, so without any kind of stationary network without any kind of coarse network services will be more or less in horizontal accuracy 2.53 centimeters and vertical accuracy about the 5 centimeter. Of course, with a convergence time to calculate the fix about 15-8 minutes. The PPP solution with TerraStar uses GPS, GLONASS, Galileo, and Beidou, and is supported only on OEM7 platform. So we can use this system only with our Zenith40 receiver. The second method to use the PPP on our software and with our receiver is to use the PPP in combination with a RTK connection. So if we use the pure PPP, we can select only PPP. Otherwise, if you want to use the PPP as a background for the RTK connection, we can select one of the RTK connection method plus also the PPP solution. This is allow us to use RTK connection, and when we cannot achieve the centimetric accuracy with the RTK connection, the software automatically will switch to the PPP service. So we already seen how it works. So if the RTK fix is more precise than the PPP, the software will use directly the RTK solution. If, for example, we are in area not covered by the RTK network and the PPP fix is more precise than the RTK, the software automatically will switch to the PPP solution. Then, for example, we move again inside our surveying area and we get back the RTK fix with accuracy more precise than the PPP fix, than the PPP solution. In that case, the software again will switch automatically to RTK fix solution and use the RTK connection. So in this second case, using the PPP plus the RTK, the PPP can be considered as a backup of our RTK connection. But to perform this solution, we need to calculate the adjustment between the RTK solution and the PPP solution. And this is how it works. So each time we select to use RTK with the PPP, the software will ask us to open the Ppp Manager, and from the Ppp Manager we can select a previous shift adjustment, so the adjustment between the RTK network, RTK correction, and the PPP network, so between the two different data, or we can select a previous PPP adjustment. So previous PPP adjustment that we can check also on maps, or select new to perform new adjustment. The adjustment will be valid for 60 days, less than 50 kilometers distance. As we already seen, we have two different methods, so using RTK points or using no points from the local network or points that we already measured before around our surveying area. After that, after selected one of these two methods, the software automatically takes a few minutes to calculate the convergence between the PPP solution, PPP data, and the RTK data. And we can check also this shifting adjustment. This shifting adjustment and all the data from each adjustment will be saved directly on our internal memory of the device, XPath folder, data subfolder. So each adjustment will be saved here with also the name of the date, or you can select also new name for each adjustment. If we have more questions, you can write me directly on chat, or if you need some some extra data, or we can also provide you some more data also related to our solution. You can write directly me on the chat, or also use our Academy email. Let's check if you have some question. Okay. Yes, okay. We have a question about the TerraStar solution and the different services. For our receiver, we can use only the TerraStar C Pro services, which means that it is the more accurate service if you compare also the other TerraStar services. For example, for the other service, the accuracy is not so accurate in comparison with the TerraStar C Pro. So the best accuracy, you will get the best accuracy only with the TerraStar C Pro. We have different solutions also to test the solution on our receiver, on our Zenith40 receiver. You can directly write to us to have more information about the service. So we have other question. So once we have waited for the convergence time, and we picked 2 points using only the Ppp service. So it means, so the convergence means that, okay, we will see together. It's more or less how we use the GPS localization for the local network. So we need to measure 1 point with the RTK, or select one no point, and then measure the same point with the Ppp. Then we need minimum 1 point, and after that the software will calculate the Ppp convergence. So it's more or less how it works, the GNSS localization, the normal GNSS localization to the local network. So measure 1 point with RTK or no point, and assign the same point with a Ppp solution. So a few minutes to measure the point. So the entire procedure takes several minutes, less than 10 minutes, to get this shifting adjustment. About for the cost of subscription, it depends on the area. You can directly go to us, and we'll give you the contact of the local dealer to get more information. Now we have to move to another location. So again. Okay. So again, we have to wait for only the first time the software, the hardware, need to calculate the convergence. So the position adjustment takes 18 minutes. If you move to another position, you need few seconds to get the accuracy. But of course, depends also on the satellites that you can track. But of course, for each point, you don't need 18 minutes for each point, but only during the first measurement, only during the calculation on the convergence time, you need 18 minutes. After that, for each point is a normal time, but that depends also on the satellites that you can track with the receiver. So it's few seconds for each point. While working with the RTK plus Ppp, so we need base and rover both instruments. So if you work together with RTK solution and Ppp, you can choose different RTK connection directly, for example, from our main menu. So using Zenith40 and the Ppp is already activated on that receiver, you can select one of the RTK method plus the Ppp solution, and after that, of course, you need to calculate the position adjustment, and from the position adjustment, then you can work with both, so with radio or with the GPRS with the GPRS solution. Yes, sorry for the cost. Unfortunately, as a technical support, I don't have the cost of the service of the TerraStar service, but you can write directly to us, and we will get you in contact with the local dealers to receive all the information. Of course, if you are already customer, GeoMax customer, we have also the possibility to create a sort of a demo, which allows you also to test this solution, but only with the Zenith40 receiver and using Echipa Ultimate. Now, as I already told you, the slides are unfortunately are not available, but tomorrow you will receive an email with the videos of this presentation. So you can also review this video directly from this link. You don't need to create another time subscription. You don't need to register it again. The video will be available. So we don't have a limitation time for the availability of the videos. If you lose initialization, what is the time it takes to gain it initialization? So in that case, if you lose the fix with the, I assume with the PPP, it takes from few seconds, maximum 1 minute to get back the PPP fix. Of course, it depends on the area. It depends on the satellite that you can track on this area. So we have more questions. Yes. Okay. Of course, if you have more questions, you can directly write us on the Academy email. We will provide you also with more details about the solution, also about our solution with our receiver and our software. And for the price, I will get you in contact with our dealer, so quite soon. And you will receive also soon some information about the service. Of course, if you want to check also by your own, you can check directly from the TerraStar so from the Novatel website, and then directly TerraStar solution and see TerraStar C Pro service. So also from the website you can get some more information about this service. But of course, I will get you in contact with our dealer. So if you have more questions, I'm here at disposal. Otherwise, you can, as I told you, write to our Academy email. For the moment, okay. So yes, on another question, we can use another PPP solution provided from a third-party company. No, unfortunately, for our receiver, for the Zenith40, we can only use the TerraStar C Pro service. Unfortunately, also the other service will be not available. For the Zenith40 and using Echipa Ultimate, we can use only the TerraStar C Pro service. I hope it is everything clear. Otherwise, of course, I will be at disposal. Thanks again for your participation, and keep in contact with the next webinar. Thanks to everybody again, and have a good evening, good morning to all of you. Thanks again.